This is the Wheatstone bridge problem, problem number 79 in chapter 20. And I will be using the loops and the junction rules that are given in the key just for consistency's sake. And I will not be solving all the algebra, but I will be setting up all the loops and all the junctions, the original equations. At that point, you could use either your calculator to solve the unknowns and the equations or do it by hand, the long one. All right, so first off, we've got to draw the circuit. And this is a classic problem in physics. And my picture is not going to be quite as good as the books, but I'm sure you will get the idea. You should probably have out your actual problem when you are looking over this. We got 1, 2, 3, 4, 5 resistors in the bridge, and then it connects to in this problem, it happens to connect to a 20-volt battery. And they give you the resistances and some points. This is point A. We have point B, point C, point D. And the resistances, I'll allow you to look them up. They are in the book. This is on page 616 in Cutnell and Johnson, our AP Physics book. Okay, so if you look at this, you could start to be concerned and say, well, can I slide these resistors together? Can I make these in series or parallel? Well, if you start to do that, you get to a problem pretty quick, okay? Because you're like, okay, well, these split off, but then they don't come back together, okay? So they might be in parallel with all of this, but then is this in series with this or parallel? It becomes extremely confusing, and it's not straightforward to figure it out. So what you need to do is forget that for a minute, okay? That's usually a step if you can see it, equivalent resistance and current. So start applying the other stuff. Now, in this problem, they did actually ask you to determine the resistance, the voltage between points B and D. So eventually we want to get to V, the potential from B to D. What does that equal? So to answer that question, we have to know the potential across this resistor. So we'll need to know the value of the resistance, which we have, and the current that goes to that resistor, so that we can apply V equals IR. Okay? And to do that, the current, let's start looking at what's going on here in terms of current. And I am going to pick the correct way for the current flow. If you ever happen to pick the incorrect way, remember, you just get a negative number. Okay? It doesn't mean any of your work is wrong. You just picked the wrong direction. So let's pick some directions for current. All right. Slide this over just a little bit. Okay. So current is going to come out of here, and it's going to get to this junction. At junction A, some of it's going to go this way, and some of it's going to go this way. Okay. And I'm going to label these as the current through their appropriate resistors. So this is the current through the 40 ohm, and this is the current through the 20 ohm. So it's current, I'll call it I-40 and I-20 to be consistent with the book. Now, at this point, it's a question. Does it go down or does it go up? Well, I'm going to pick the appropriate way, but there's no way of knowing that intuitively. You just have to pick a direction and go with it. So I'm going to pick down and call this the current through the 60 ohm resistor. At this point, we can think it's eventually going to go back to the battery. So some of it goes off like this, some of it goes off like this. That'll be I through the 70 ohm resistor. At this point, once we pick this direction, we don't have any choice here. Okay? Current's coming in to point D from both directions. It has to go out somewhere to go back to the battery. So we know this current, based on what we've drawn here, has to go that way. And that is current through the 50 ohm resistor. So I've picked all these directions. Once I pick these directions, I need to label my resistors for the voltage drops. So this will be plus minus, plus minus, plus minus, because the current's going that way through the resistor, plus minus, and plus minus. Now this looks like a mess. So at this point, you may want to pause and put this on your own paper so that you've got it down. And if not, go back and replay as I was walking through each one of those. But it looks a little messy up here, and yours look a little messy too. But as long as you follow the notation, it's okay. There's a lot going on here. It should be looking a little messy. All right, now at this point, we can start applying junction rules and loop rules. Junction rules aren't too bad. So let's apply the junction rule at B and D. Okay, so I'm going to do the junction rule at B. Okay, at point B, and I'm picking the ones that work. Okay, you could do this by trial and error and try all of them and have lots of equations. It makes it a little bit more difficult, so I'm going to just skip to the ones that happen to work out for the system equations one way. There's probably more. I know there's more than one way to solve this. So at junction B, what's going on? Current 40 coming in right here, and then current 70 and current 60 going out. Remember, this just corresponds to the R. It doesn't mean there's 70 amps or anything like that. It's just a way to keep track. I could have called this I1 and I2, I3 and I4 if I so chose. This is just subscripts, so just to keep track. So we have current coming into B, I40, and then it splits up. And the current that came in has to equal what goes out. The river analogy. River comes in and forks. Whatever comes in's got to go out. So it'll be I60 plus I70. Okay, that's at junction B. Now let's apply it at junction, I believe it's D. Let me double check. I'm just going to do the ones the book did. Yep, at junction D. So we look at point D, and this is the junction rule once again. We have this coming in from this direction, current coming in from there, current coming in from here, and current going out. So at junction D, what's going in? The I60 has to equal, oh, we got more coming in, sorry. We have I60 coming in and I20, current from the 20 resistor. Both of those are going in, and then that has to be equal to what's going out, I50. Okay. Now, what we're eventually going to need is the current through the 60 ohm. Right now, we have 1, 2, 3. There's 60 again. 3, 4. Looks like we have 5 variables and 2 equations. So we got problems. We certainly cannot get there from here. So we need way more equations. Okay? We need at least 3 more equations. So I'm going to erase this. So if you don't have it down, pause the video and go ahead and get it down. And I am going to apply the loop rule to get some more equations. And then you'll be able to solve once these are all set up. Okay. I am first going to loop around A, B, D, and then back to A. So this will be loop A, B, D. And then, of course, if it's a loop, if you started at A, you're going to have to make it back to A. Slide this over just a little bit. Okay, I think we're all right. So taking a look at this, A, B, D, A. Here's A. So we start here, go to here, A, B, D, A. So this is the loop that I'm applying, okay? And I'm going to go ahead and go this way across it, okay, across it. Now, this is where the resistors matter, where you put the plus minus, because you're going to have, if you go this direction, I'm going to go clockwise for this loop, you have a potential gain, potential drop, excuse me, I misspoke. Do this again. Going clockwise right here. Here you have a potential drop, and here you have a gain. If you have drops, at some point you're going to have a gain. And even though it's across the resistor, that's just because of the direction that you're looping. So the plus minus does matter. That's why we had to put it on the picture from the beginning. So let's go ahead and loop that. And we'll write the equation here. We have current through the 40 times the resistance of the 40, which is 40 ohms. Okay, that is a drop. We've got another drop right here. That'll equal the gain. So we have another drop. So I'm doing drops on the left. So we have current through the 60 times 60. And just because I'm running out of space a little bit, I'm going to put equals. This part here equals the gain, which was the current through the 20 times 20 ohms. So we have another equation, and we haven't introduced any more unknowns because we had I40, I60, and I20 before. So we've got another equation. That's a good thing. Okay, that's loop A, B, D, A. Now I'm going to go ahead and loop B, C, D. And if it's a loop, you go back to where you started. So B, C, D, B. Okay, so B, C, D, B. There's my loop. So I'm going to go clockwise again. I'm going to take a look at it. Here we have a, if we're going clockwise, here we have a, we're going from plus to minus, here we have a drop, here we have a gain, and then going clockwise, got to pick a direction, here we have another gain. So we have 2 gains and a drop. So these two will be equal to this one. Drops are equal to gains, or gains are equal to drops, however you want to say it. So let me keep this straight. I'm going this way, so this is a drop. So current through the 70 times 70 ohms. Plus, that's a drop. Let's see, I've got, plus to minus. minus to plus minus plus. That's going to equal my gains. This one, current through the 50, times 50. And I think we're almost on the edge. Plus, slide this over a little bit for a minute. Plus, we've got the 60, which is also a gain. So current through the 60 times the 60. There's another equation that we've just written. Yep, I think we got it on there. Let me see, double check. Yep, there's another equation we've written where we already had I-50, I-60, and I-70 in our equations. So we've got another equation. So now I think we're up to 4 equations and 5 unknowns. So we need one more equation. So one more loop that doesn't introduce any new variables. That's the key. And that's why you could have done way more loops and picked and chose which ones you wanted to use. So I'm going to erase these 2 loops. If you don't have them written down, pause, jot them down. And now we're going to take a look at loop ADC. And not surprising, one of the loops is going to go through the battery. Slide this back over a little bit. All right. So ADC, and then of course back to A. So A, D, C, oh wait. ADCA. ADCA. Yes, that goes through the battery. ADC, and then back to A goes through the battery. So let's take a look at this in terms of drops and falls, and we'll go ahead and go this way. This will obviously be a gain, voltage gain. And then going through here, this will be a drop. We're going the right way through our resistor. This will be a drop. So this is probably the easiest loop to see. But I want to draw on this one just so you can see this loop. It doesn't look like a circle. One like that. There's my loop. As long as it's a loop, you get to apply this. So the gains, 20 volts, equals the drops. Current 20 times the 20 ohm resistor. There's a drop. Current through the 50 times the 50 ohm resistor. There's another, get some space here. Current through the 50 times the 50 ohm. Oh my goodness. I promised you'd be better with the handwriting. I practiced this yesterday on that board. It'll get better. I'm not used to writing on this board. This is the movable one to reduce glare, so it will be to your benefit eventually. So 20 volt equals, this is the gain, these are the drops. And I picked that, the reason that these were drops from the resistors is not just because they're resistors, but because of the direction we go through. So we define this to be plus and this to be minus, so if we go through this way, it's a drop. If we go through this way, it's a drop. If I had picked the other way, the answer, the equation would be the same when you're solving. You just would have had both of the resistors as gains and the battery as a drop. Okay, so it depends which way you go through. At this point, we still haven't introduced any new variables, I-20, I-50. Now you can solve for all 3 or all 5 of the values for current that we had in our original 2 junction rules. And of course, the one we care about is what is I-60. So do the math. If you happen to have a computer or a calculator handy that solves systems of equations, plug it in. Okay. Once you get I-60, then you want to know the V from B to D. That was the original thing we're trying to find. Well, the voltage from B to D, since it's across that resistor, will be the current through the 60. V equals I R. You could also find the voltage across everything here. And if you know enough about this current, you could even find out the total current running through the system. And backwards from that, you could figure out what this has in terms of equivalent resistance. And that would actually be the easiest way to do it on this one, which is not an easy way at all. If this was too quick, let me know. This is a test. Also, if the handwriting is not legible on your screen, let me know. I mean, any more so than normally my handwriting would be on the board. And if there's any audio issues or playback issues, like I did something too quick and it turned into a slideshow, you couldn't see what I was pointing, please let me know that as well. That is all.